All right, guys. What we're looking at next is our power reduction formula. Power reduction formula. So with that here, so for this one, rewrite sine to the fourth of x in terms of first powers of the cosines of multiple angles. So what we want to do is we want to rewrite sine to the fourth of x as cosine. Now what's inside the parentheses doesn't really matter. If it's x, 2x, 4x, 6x, that's fine. We just do not want an exponent. We do not want an exponent attached to any of our trigonometric functions. Now, to do that, we can use the reference page. Because if we look at our reference page, our reference sheet, our power reduction formula states that sine squared of x is equal to 1 minus cosine of 2x over 2. So we can reduce sine squared to 1 minus cosine of 2x over 2. Now the issue with this here is that we have sine to the fourth, not sine squared. But to fix that issue, well, sine to the fourth is just the same as sine squared squared, because powers of powers multiply. Let's focus up here. Now, since we do have sine squared, we can replace sine squared, what's inside the parentheses, with our 1 minus cosine of 2x all over 2 squared. And whenever we square something, we're just saying that we're multiplying it by itself. And we're going to have to multiply this out. So we're going to have to multiply through the top, and we're going to have to multiply through the denominator, the bottom. Now the bottom, 2 times 2 is 4. That's the nice one. We will have to distribute the top, so our 1 times 1 is 1. 1 times negative cosine of 2x is negative cosine of 2x. Negative cosine of 2x times 1 is negative cosine of 2x. And our negative cosine of 2x times negative cosine of 2x is going to be plus cosine squared of 2x. At this point here, we're going to have to combine like terms. So our cosine of 2x minus cosine of 2x is going to give us negative 2 cosine of 2x. Questions on this here? Well, we do have this all in terms of cosine, yes? Do we have any exponents left? Yeah, we have cosine squared, yes? So we need to reduce it further. We need to make sure we do not have any exponents left. Now, there's a few things we can do to get there. Now, one of them is making this a little bit simpler, because this whole thing is being divided by 4, or we can say that it's being multiplied by 1/4. We can pull that fraction out. Now, part of the reason that's nice is now we have 1 minus 2 cosine of 2x plus cosine squared of 2x. We don't have that fraction anymore. It's going to make it a little bit easier to work with. Mainly because we're going to have to use this power reduction formula with cosine. Because it says cosine squared of x is equal to 1 plus cosine of 2x over 2. Because if we left that as whole expression over 4, we would now have a fraction in a fraction, and we'd have to reduce it. So factoring out that 1/4 does make this a little bit easier to work with. Because at this point here, we still have the 1/4. We still have the 1 minus 2 cosine of 2x. plus, we need to put this power reduction formula in. We'd have the division of 2. We'd have the 1 plus cosine. But we don't have x. We have cosine of what? 2x. So inside here, we'd have 2 times 2x. So really, we have 1 plus cosine of 4x over 2. Questions on this here? Not what I wanted. Questions on how we got to this point here? Now, the last thing we're going to do to make this a little bit simpler is to get rid of this fraction for this here, and we're going to turn it into 1 plus cosine of 4x. Now, to do that, we're going to factor the 1/2 out, that division of 2 out. So out front, we will have the 1/4 times 1/2, because we factor that half out. Now, we have to factor that 1/2 out of the 1. And essentially what we're doing is dividing these terms by 1/2. Because that's all we do when we factor something out. We're dividing that amount from each term. Now, normally it's fine, because if we factor out a 2, we're dividing by 2. But when I factor the 1/2 out, well, we can say we have 1 over 1/2, which is 2, or 2 over 1/2 is 4. So really what that leaves us with is 2 minus 4 cosine of 2x. Because again, it just increased the value. Because 1/2 times 2 is 1. 1/2 times -4 is our -2. We have some last two things. 1/2 times 1/4 is 1/8. 2 plus 1 is 3, minus 4 cosine of 2x plus cosine of 4x. I think we can agree it's not so much that this problem is difficult as it is tedious. It's a lot of manipulating the equations. Questions on this here, this power reduction? I'm not going to make y'all go through the pain of doing, not pain, but tediousness of of tangent to the 4th. And that'll bring us to this here. So, we want to find the exact value of sine of 105 degrees. Now, 105 degrees, if we looked on the unit circle, is going to be over here in the second quadrant, because 90 is straight up. 180 is our negative x-axis. Well, 105 degrees is not on the unit circle. 105 degrees is not on the unit circle. But 210 is. Now, one of the things, and the reason we're specifically picking 210, is how is 210 and 105 connected? 210 is or half of 210 is 105 degrees. And the reason we picked this and the reason we're doing this is our half angle formula. Because sine of theta over 2 is equal to plus or minus the square root of 1 minus cosine of theta over 2. And this here is our half angle formula. Now the plus or minus, which sign we take is going to depend on which quadrant our original angle is in the sine or cosine value. Now since 108 degrees is in the second quadrant, sine is going to be positive, cosine is negative, and tangent is negative. So since we're taking sine of 108 degrees, and since it's in the second quadrant, it means that sine of our angle, 210, over 2 will give us a positive value. So we set this up as sine of 210 degrees over 2 is equal to 1 minus cosine of our angle. And our angle is going to be 210. And since we're in the second quadrant, this is positive. Now at this point here, we can use the unit circle. That's the whole reason we're doing this, to be able to find the value of cosine of 210 degrees. Well, cosine of 210 degrees is negative square root 3 over 2. Now, luckily for us at this point here, we can type everything inside the radical, not so much the radical, but everything inside the radical into the calculator. Because we can say 1 minus negative square root 3 over 2 all over 2. Which gives us this here, 2 plus the square root of 3 all over 4. Now we do need to simplify this radical, and really what we do to simplify is we take square root of the top over the square root of the bottom. Now for us, we're going to leave it as the square root of 2 plus the square root of 3. However, the square root of 4 is 2. So our final answer is the square root of the quantity 2 plus the square root of 3 all over 2. Questions on this here? Yes. Now we can look at sine of 105 degrees. And we get this here. Also might help if we are in degrees, not radians. Throw that out. Sine 105 degrees is this here. Now we said our answer was the square root of 2 plus the square root of 3 over 2. So this here is our answer. And they said the answer was what? This here, yes? Well, if I subtract the 2, we get 0. Well, the only way I can subtract the two values and get 0 is if the two values are the same. Yeah. So it just gives us it in a little different format. The 30xs is getting rid of that square root inside of a radical. We get a radical inside of a radical. Questions on this here? Well, now we're going to find the exact value of cosine of 105. Well, just like we saw, this is the exact same as what we just did, cosine of 210 degrees over 2. And for our cosine theorem, it's equal to plus or minus the square root of 1 plus cosine of our angle, which would be 210, over 2. And at this point, we already found out what cosine of 210 degrees is. We had it on the last one. It's negative square root 3 over 2. So that tells us we can calculate what's inside. 1 plus, parentheses, negative square root 3 over 2. All over 2 is 2 minus the square root of 3 over 4. And just like the last one, we can't take the square root of the top, but the square root of 4 is 2. And we're almost done with this problem here. Questions on this so far? Now, in the theorem, it had plus or minus in front of it, and it's all dependent on the sign of cosine, or sine where the starting angle was. So for 105 degrees, cosine is negative, which means this is going to have to be negative. Now, I didn't ask for this, but we can go on and find tangent of 105 degrees. Yes, because tangent of theta over 2 has one of 4 different forms. Because we can say that it's plus or minus the square root of 1 minus cosine of theta over 1 plus cosine of theta. We could also say that it's 1 minus cosine of theta over sine of theta, or sine of theta over 1 plus cosine of theta. We could say that it is all of these here. Or we could say that, yes, that tangent of theta over 2 is equal to sine of theta over 2 over cosine of theta over 2. Now, if theta over 2 was a nice answer, these work fine. But since sine of theta over 2, cosine of theta over 2 are these here, trying to divide those is nothing that is going to be bad. It's just going to be a little challenging. Because I would use one of these two here. Because we can use this second one. This would be 1 minus cosine, because we're looking at tangent of 210 over 2. We're trying to find tangent of 105 degrees. It would be 1 minus cosine of 210 over sine of 210. 1 minus negative square root 3 over 2 over 1 minus negative 1/2. So we have 1 plus the square root of 3 over 2 over 1 plus 1/2. 1 plus square root of 3 over 2 over 1 plus 1/2 is 2 plus the square root of 3 over 3. And that's all we'd have to do for that there. And we would get the exact same value for the other one here. All right, guys, questions on this here? Find all solutions for 1 plus cosine squared of x is equal to 2 cosine squared of x over 2. Now we have a few issues with this here. Mainly the power and the half angle. Now the first thing I would look at is our half angle. Our half angle formula. Cosine of x over 2. Theta over 2 is equal to plus or minus the square root of 1 plus cosine of x all over 2. So the first thing we can do is plug this in for our cosine of x over 2. Now the left-hand side is going to be still 1 plus cosine squared of x is equal to 2 times our plus or minus the square root of 1 plus cosine of x over 2. And it's still being squared. Now, one of the interesting things, especially with this here, is, well, the plus or minus, if we square it, because we're multiplying it by itself, if it's positive and we square it, it's going to stay positive. If it was negative and we squared it, it becomes positive. So the plus or minus is gone. It's just plus. And the square root and square will cancel, telling us 1 plus cosine squared of x is equal to 2 times 1 plus cosine of x over 2. Now you might be wondering why the square did not affect the 2 in the bottom of that fraction. Well, that's because that 2 was also inside the radical. The 1 plus cosine of x all over 2, everything was inside the radical. So when we squared it, it went away. Also, our 2 and 2 here, that multiplication will cancel, telling us that we have 1 plus cosine squared of x is really equal to 1 plus cosine of x. Questions? Questions on any of this here so far? We good? No questions on what's canceled, what's simplified? Okay. Now at this point here, we need to get this equation equal to 0. So the first thing we can do is subtract 1 from both sides, telling us that cosine squared of x is equal to cosine of x. Then we can subtract cosine of x from both sides. On the right-hand side, the cosine of x minus cosine of x is indeed 0. However, cosine squared of x and cosine of x are not like terms, so we can't combine them. Just telling us that we have cosine squared of x minus cosine of x. Questions on how we got to this point here? Is there a greatest common factor between cosine squared and cosine of x? They both have a cosine in common. No, you're good. Because we can factor that cosine out so that we can be able to solve it. Because if I have two things multiplied together to equal 0, one of them has to be 0. So cosine of x times cosine of x minus 1 is equal to 0 is telling me that either cosine of x is 0 or cosine of x minus 1 is 0. And between these two here, one of them is already solved. We need to solve the other one by just adding 1 to both sides, telling us that one of them, we have to have a cosine value that is equal to 1. And the other one, the cosine of x has to be 0. Now for our cosine of x equals 0, we can look at the unit circle. And it's telling us that the two main angles for which cosine of x is 0 is pi over 2 or 3 pi over 2. Now, the values at which cosine of x is equal to 1 is specifically when x is equal to 0. Now, if it restricted us on the interval of 0 to 2 pi, these would be our three answers. That'd be it. If we wanted to find all the possible solutions, we just have to add its period back in times n. Since the period of cosine is 2 pi, we add 2 pi into it to get all of our coterminal angles. And yes, 0 plus 2 pi n we can just write as 2 pi n. If it told us it's between 0 to 2 pi, we're just looking at 0, pi over 2, 3 pi over 2. If it wanted all of them, we have to add the 2 pi n back in. Questions on this here? All right, we'll wrap this up tomorrow.